Alright, we are in geometry. We are on lesson 1-3. Today we're talking about angle bisectors and copying angles. But before we talk about angle bisectors, we need to define what that is. So, if I have an angle AOB, and let's go ahead and draw a little picture out here to see what's going on. If I have an angle AOB, so here is A, here is O, and here is B. You're copying this down with Mr. Sindel. We are on page 12 right now, yes. Yep. So, angle bisector, I'm going to assume that C is going to be the midpoint of BA here, just for the sake of making sure that we actually are bisecting the angle. So I'm going to make this dot, this point in between A and B halfway. It's the midpoint. So I'm going to call this angle C, and label it not to the right of it, but above it or below it, because we're going to be drawing a line. Everyone has a straight edge, I would assume, from the warm-up. So we have this angle AOB, and C is on the interior. All right. So the interior obviously is on the inside of the angle. That's what the interior is defining. If I do a point out here, it's on the exterior. So I have C on the interior, an angle bisector. So C is on the interior of AOB. If C is equidistant, and I'm going to pause right there. What the heck does equidistant mean? Dissect that word. There's two parts there. There's equi, and then there's distant. Two words that kind of are straight, or not straightforward, but give hints at what the word means. Anna?
An equal distance from two different points?
Yeah, equal distance. Equal distance. So we can just write about that if you don't like that word. Equal distance. If C is an equal distance between A and B, then the ray OC, not OG, but OC. And by the way that we mark a ray is with an arrow just to the right, not to the left. And I think we've already reviewed rays before, so we should be masters of rays. Colby, can you please shut your laptop? A ray is a... Okay. So ray OC bisects the angle AOB. So we're copying all that down. Now let's take a look at what's actually happening here. So with your, I guess, straight edge, I should have been doing that from the very beginning. With a straight edge, we're going to be just making this ray that comes from O through C. What we are doing here is we are bisecting the angle. Bisect, if you don't like that word, again, the other way of writing bisect is cut in half. This word bisect, cut in half. We are cutting this angle in half. We are making this angle bisector. We need to learn how to do this via construction. Construction is a word that just means we're using our compass to make sure it is mathematically true. Regardless of what angle I'm given, I can construct an angle bisector. We can do this with technology using GeoGebra, or we can just use the compass. Today we're using the compass, and for homework we're going to be using the compass. So the other important part is this. the measure of AOC is equal to the measure of COB, that means that the angles are equal. That means that this angle AOC, we're going to mark this angle right now, this angle AOC and this angle COB, those are, what's the word I'm looking for? It starts with a C. Anyone want to get some XP? Go for Ellery. Congruent. No. You didn't get XP. Yeah. Next time. All right. So let's go ahead and I see some people still writing. So make sure that we have all of that because it is super important when we start bisecting angles for homework tonight. Let's go to the next page. Mathematical modeling exercise number 1. Bisect an angle. I need a quiet raised hand with a beautiful voice. By the way, all of you have beautiful voices, so that's anyone in here. Beautiful voice to read just this paragraph. We need a compass and straight edge. We have that, so I need to start reading with Joey and his brother, India.
Joey and his brother, James, are working on making a picture frame as a birthday gift for their mother. Although they have the wooden pieces for the frame, they need to find the angle bisector to accurately fit the edges of the pieces together. Using your compass and straight edge, show how the boys bisected the corner angles of the wooden pieces before to create the finished frame on the right.
Yeah, so we need to cut those angles in half. And this is true with anything dealing with framing. Side note, Mr. Sindel's mom worked for a framing store for 3 years, so I know quite a bit about framing. And yeah, you do need to have this 45-degree angle so that these pieces fit nicely together. Otherwise it looks all blocky like Minecraft. So, and Colby actually wants that. So, sorry Colby, we're actually going to go to this version. So how are we going to bisect that angle? So, thank you. Is your name on it?
It's on the back end.
All right, perfect. All right, so we're going to be using our compass and our straight edge. The first thing that we're going to do is we're going to create this point here. So draw this point. We're going to label this point A. It's small, but we're going to be able to do it. This point is A. Label it A. It doesn't matter what distance we choose for this horizontal distance, but I'm just going to randomly say, I'm going to choose the corner. I could have chosen right there. I could have chosen there. I'm going to choose the corner, and I'm going to call it B. We've made 2 points. You're doing this with me.
Are we supposed to write everything on the second page that you just were writing?
Everything right now that I've been writing, you're writing. Yes. Okay. So, compasses at the ready. With your compass, we are going to make a full-on circle with center A that goes through B. So I'm going to try to do that to the best of my ability by estimating the size, shrinking this, shrinking this down right about there, a little bit smaller, and let's make this a little bit thinner, not too thin. All right. So we should have this circle. By doing that, we have measured the distance from A to B. We know that the distance between A and B must be the same distance between A and this intersection point on the edge because a compass just measures things. A straight edge doesn't measure. I know it's rulers, but the way that we measure is with a compass. We can say that this new point, this intersection of the side length, this new intersection point, we can call that C. Everything that I'm saying right now, you need to know because you're about to do this on your own with a brand new angle. The first thing that we're doing is getting these 2 points equidistant from that vertex of the angle. Get these 2 points equidistant. That was step 1. Now that we have these 2 points, we need to say where is the midpoint between these 2 points. And I'm about to show you how to do that. With your compass, you don't have to have the original measurement anymore. You just have to have a measurement that's at least slightly larger than halfway. So if this between here and here is your measurement, that's not going to work. It needs to be slightly larger. So it needs to be between here and maybe here. That's slightly larger than halfway. You could do, notice that larger than halfway could be between here and here. That is bigger than halfway. In fact, that's the one I'm going to choose. I'm going to measure between C and B. So I'm going to rechange my compass. So I'm measuring between C and B, and I'm going to make that circle around C.
Yeah, I don't know.
Make a circle around C when the compass measures between C and B.
So the length of those two make a circle.
So the length of C and B, make a circle around C. And this is what it should look like. I'll try to do my best.
Didn't work out.
I'm going to guess it looks like that. Go around C. Needs to be slightly larger. So that's currently what I have. A circle that measures between C and B that goes around C. I know it's a little bit offset. So far, so good. Give me the thumbs up if you're done with that step. And you're not giving me a thumbs up because you're still working on it. Okay, that means that there are 4 people still working on it. I'm going to pause. I'm going to not change the distance of my compass and make that same size circle around B. With technology, that means I just copy and paste.
Yeah.
Same size circle around B. I need to get this exactly in the center. So this is the picture that I currently have. Notice now that this intersection between those 2 big circles around B and around C, that intersection point right here matches up with this line. It's a little bit off on mine, but it should be almost perfect on yours because you actually have a compass. Go ahead and mark that intersection point. Let's call that intersection point D. If we connect A to D with a straight line,
Mine doesn't look like that.
I'll come and check yours in a sec. If we connect A to D with a straight edge, and mine was a little bit off because I'm using technology and not using a compass. I need a compass tool on here somehow. If I connect A to D, it should be perfectly bisecting that angle. I'm going to come around and see how we're doing. All right, so we are going to bisect all 3 of these angles. The first step is to get a point that is equidistant from the vertex. So you can choose whatever length you would like. I can choose between here and here. I can choose between the point and here. I don't care where it is. Somewhere along here, it needs to be some distance that you choose. You just choose one. I'm going to just choose wherever my circle lands because I don't have a compass. That is not the right tool. I'm going to choose this length right there. Oh, I have to make it smaller because I can't go off the page.
Are you your own boss?
Of course. All right. So I have a circle going around my vertex. I'm going to label this just so that you can follow along. But you should make a habit of labeling each new point a new capital letter. By the way, points, I usually do capital letters. Line segments, I usually do lowercase letters. All right, so I have a point A, and it intersects at these 2 points, which happen to be equidistant from A because this radius is the same as this radius. So I'm going to call this point B, this point C. Let's walk around and see if people are doing that. Yeah, I'm on the test. I'm going to make sure that I'm good. Piece like that, and a long piece like that. All right, looks like a lot of people are already going to the next step, which is awesome because you know what you're doing. So the next step is I need to make a new circle that measures between C and B. It doesn't really have to measure C and B. It just has to be some random length that's slightly longer than halfway between C and B. I could even use that same circle again if I wanted to. I'm pretty sure I could. Let's see if I can grab it. Oh no. If I grab this circle, oops. Copy, paste it, and put it around C. I'm going to make a new circle around B as well. The circle around B and the circle around C have to be the exact same radius. You can't move your protractor. Or not your protractor, your compass. That was a slip. So I'm making the same size circle around B and the same size circle around C. Once I find their intersection point, one of the intersection points happen to be almost exactly on A because I have the same size circle. Once I find the intersection point, I construct a ray, or even just a line segment, that goes through that new point, and I can label that new point, just make a habit of calling it point D, a new ray AD, and I have now made an angle bisector. This length here is the same as this length here. So this angle is congruent to this angle. I have made an angle bisector. That's how to construct an angle bisector. Your job is to do an angle bisector for the second and third example, and then to write down the steps so that you can remember it in the future. So I'm going to be walking around and helping us do that right now. But that's our project. Construct an angle bisector for the second and third example, along with writing out the steps. All right, so we are now on the next page. We are on page 15. We are copying an angle. So this is the angle that we want to copy. We want to copy it somewhere out here. So with your straight edge, go ahead and make a line. Your line can be the same angle right here, or it could be right here. It will still be the same angle regardless. For the sake of just showing you how they look the same, I'm just going to make a line segment that's slightly longer than this line segment right here. Of course, I could just eyeball it and say, okay, I think that angle looks like that, but I don't know if it's actually that angle or not. I have to do it by construction. So this is how you do it. First, use your compass and measure some distance. I can measure the distance between this point and here, this point and here. It doesn't matter. I'm going to just make my compass and measure some distance. No, this is super important. Go to the bathroom in 5 minutes after I finish. All right. Let's start labeling things. This vertex point, let's call that point A. Let's call this new intersection point on the right-hand side point B. And this intersection point at the top, point C. So far, so good. We can figure out what the same distance between A and B is over here. If I say that this is my new point, I'm going to call this point Z. I'm going backwards with the alphabet. Z, Y, X, W, V, U, T. If this is point Z, I can find the distance between A and B over here because the compass is just used to measure. Use the same compass measure, don't move it, and make a new circle, the same circle around Z. The intersection between this line and this circle is our new point. It's the same distance between A and B is the same distance between Z and Y.
Oh, mine didn't intersect.
It doesn't have to intersect this circle. This circle right here just needs to intersect the line. So I make the same circle around A as the same circle around Z. the same radius around A, same radius around Z.
Mine just looks like that.
Where the circle around A intersects the angle is B, where the circle around Z intersects our new line segment that we drew is going to be labeled Y. So far, so good.
What if my circle didn't intersect through the other one? It's just barely on the line.
It doesn't matter. It doesn't have to intersect. This could have been 10 miles away. This line segment doesn't have to be that close. It's just we're constricted on space for our book.
Okay.
All right. Now we're basically there. We have one more move left. We somehow need to say, I need to get this new measurement. I somehow have to measure this angle, but with a compass. A compass measures things. How can I measure somehow the distance this way? What 2 points could I measure? Anna. C and B. There that is. So with your compass, use your compass so that you measure the distance between C and B. Just open up your compass so that it's perfectly, 1 point is on B, the pencil is on C. So you're measuring between B and C. With that same measurement, move your compass over so the point now of the compass is on Y, and the pencil will come up here and make an intersection mark. So I'm going to have to do this with technology to the best of my ability.
I have no idea.
I'm going to guess right there.
Yeah, as soon as you said move your point to this, you lost my number.
All right. So my compass right now measures between B and C. So everyone has the correct measurement on their compass. Their compass isn't moved anymore.
Correcto.
All right. So with their compass, your compass now, the point of the compass, the metal end, put it on Y. The pencil end should come somewhere over here. Where does the pencil end intersect this line? What you're going to do is you're going to make a little arc wherever it intersects this new circle. We're measuring the distance between Y and our new point, just the same way as we measure the distance between B and C. We're just measuring the distance of this angle. The distance of the angle is between B and C. Distance of the angle is between Y and this unknown coordinate. We can find that unknown coordinate with the compass. So with technology, what that looks like is I have to grab this circle and put that same size circle, around Y. Oh my gosh, it's so much lag.
I'm so lost.
I'll come to you in a sec then. I'm putting that circle around Y. And then that intersection point right up here, we're going to call that X. Somehow there should be an intersection point up here labeled X. It's just measuring between Y and X is the same distance between B and C. And then we make a ray from Z to X, and we have copied the angle.
Ooh, look at this.
Notice that copying an angle and bisecting the angle had the same first steps. We needed to have a point that was equidistant from the center of the vertex of the angle, rather. B and C were created by creating a circle around A. We did the same thing for copying an angle and bisecting an angle. The only difference is bisecting the angle, we needed to find a midpoint. For copying an angle, we just had to measure the distance of the angle, this distance between B and C, and copy that distance over here. All right, how much time do we have left on a Thursday? We get out of here at 43, which means we have 50 seconds left. Your homework tonight. Your homework tonight is numbers 1 through 5. Do every single problem here. Numbers 1 through 5. You're going to have to take the compass home. Please don't forget your compass at home because then we won't be able to do the lesson tomorrow. Do numbers 1 through 5. All of the problems on page 17. I'll put it on you guys as well. All right, that concludes the lesson.